Hello everyone, welcome to the new chapter on electromagnetism. Before we proceed any further, now let us do some recap on what we covered in current electricity and DC circuit. Now for a start, all of us are familiar with this basic diagram. We have a battery, a resistor, and we know that the conventional current flows from the positive terminal of the battery to the negative terminal. And this is how you draw the current flow. However, when it comes to electromagnetism, we need to see diagrams in a three-dimensional way. So when I draw the current in this fashion, I can only draw on a plane, on a flat surface. But how are we going to illustrate it in a three-dimensional way? So on the diagram here, you can see two circles. There's one with a cross and one with a dot in the middle. So the cross, this represents current flowing into the plane. So what is a plane? Now, a plane is simply a flat surface. And there's nothing scientific about this word. It is a very plain, simple English word. Please refer to the dictionary for the meaning. Right? It's just a flat surface. So the cross represents the current flowing into the plane, and the dot with a circle represents current flowing out of the plane. So one is flowing in and the other is flowing out. So note how the current is drawn. Next, let us explore what do you mean by electromagnetism. Now the word electromagnetism comes from the word electro comes from the word electricity, and magnetism is, well, magnetism. So this is our beginning. This is a point where we have to understand that electricity and magnetism must coexist. We can't have one without the other, and hence I'm going to introduce you this diagram here. Now what we have here right in the center, marked out in red, is actually the current flowing out of the screen, and the black circular line surrounding it actually represents the magnetic field surrounding the current. So how do we know the direction of the magnetic field? So for a start, let's introduce to you this thing called the right hand grip rule. Right, in the right hand grip rule, the thumb, this is a thumb, right, you point the thumb in the direction of the current. So that means in this diagram given here, you point the thumb out of the plane. Next, the direction of the fingers. As I drew in the green marker here, the direction of the fingers is actually the direction of the magnetic field. So in the right hand grip rule, when you align the thumb coming out of the plane, the four fingers will form a circular ring around the thumb, and this circular ring the points in the direction of the magnetic field, and hence that's how you draw the arrow as indicated here. Here, this arrows point in the direction of the four fingers. So using right hand grip rule, we are able to determine the direction of the magnetic field for a current coming out of the plane is in the anti-clockwise direction. So we can say direction of magnetic field is in anti-clockwise direction. Also note that the magnetic field lines also the number of magnetic field lines represent the strength of the magnetic field. So I'm going to highlight this section here in yellow. And I'm going to highlight another section here in green, in cyan. Now, do you notice that for the section in yellow, the magnetic field lines are closer? This means magnetic strength is greater. However, for the ones marked in cyan, you realize that the magnetic field lines are spaced further apart. So that means the magnetic field lines are further apart, and hence the magnetic strength is weaker. Okay, let me find the space to write it. So the magnetic field lines are further apart. This means magnetic strength is weaker. So we're going to put all these things together. Now we don't notice that as the magnetic field, as you move further and further away from the current, the magnetic strength becomes weaker and weaker. So we go to another diagram. Right, for this one, I'll go a little bit faster because the idea is the same. It's just there's a difference in the direction. So right in the center, you can see this circle and a cross. So that represents the current flowing into the plane. Now, using a right-hand grip rule, you point the thumb into the plane, and the four fingers wraps around the thumb, follows the direction of the magnetic field. So in this case, we say the direction of magnetic field is clockwise. The direction of magnetic field is clockwise, and the magnetic field lines, the number of magnetic field lines also represent the strength of magnetic field. So the lines that are closer together, nearer the conventional current, they are actually the magnetic strength is actually stronger, and further away, the magnetic field lines are spaced further apart. So we say the magnetic strength becomes weaker. So as we move further away from the conventional current, the magnetic strength actually becomes weaker.